Okay, so yeah, good afternoon, guys. So today we'll look at memory management and performance optimization, right, in Android development. This actually is a very key aspect, right, in when it comes to building applications. So it's because it's not enough to just okay, you put in your views, you put your design, you put your logic, and then you build your APK and you send it out to Play Store or App Store, whichever one, and then you think you're done, right? There's a whole lot of things that you still need to pay attention to, and yeah, one of which is what we're going to be talking about today, which is memory management and performance optimization. Okay, now so let's just start, right? I'm just going to just more like an overview, right? I'm sure you've heard about this before. Okay, so but these memory management and performance optimization, they are very, very crucial aspects of app development, right? Very crucial because they actually ensure that your app runs efficiently, okay? They ensure that your app runs smoothly and then it consumes resources judiciously. So it only consumes resources that it needs per time, right? It doesn't just take up everything that it needs. No, it take up what it needs per time, right? So now looking at memory management for a start, right? So it's just the practice of managing your what memory. You're basically allocating memory resources effectively within the application, right? Because applications, Android apps, right, they're actually kind of executed in what we call a resource constrained environment, right? Resource constrained what environment, because everything that needs to be done on your application requires a resource, right? And one of the things you would not want is two things, needing one particular thing that could actually bring about why your phone's applications get slow and everything, right? So apps actually are executed in a resource constrained environment. So that's why you need to properly manage your what memory to avoid things like memory leaks, crashes, and then like sluggish kind of performance, right, in your application. So now just a few things. I'm just going to say this stuff, right? So something to pay attention to, right? Some key points in memory management, right? We have what we call garbage collection, right? Android actually has what we call a garbage collector, right? Basically, what that does is just reclaim the memory that has been occupied by objects that are no longer in use, and it does that automatically, right? It actually does that automatically. So, um, garbage collection, right? Very, very important. But of course, if you're not managing your object references, right, very well, you can have memory leaks, right? Where objects are not properly, garbage collected, right? Another key point in memory management, right, is when you get to use life cycle components, right, life cycle aware components, right, activities, fragments, and any other components, you should actually manage them in such a way that they are properly released when they are no longer needed. We'll look at some key points though, right? Release them when they are no longer what's needed. So if you actually overlook a proper life cycle management, right, definitely you have memory leaks, like definitely, right? So that's just something to take note of. Now with respect to performance optimization, right, basically that just involves you enhancing the speed, the responsiveness, and the efficiency of your application's execution. That's basically what performance optimization is all about, right? So it just ensures that your application, right, just provides this kind of seamless user experience, right? Because you're actually utilizing the system's resources effectively, right? Now, when we talk about performance optimization, we can look at things like UI rendering, right? How are you rendering your user interface, right? How you do that actually is very, very crucial, right? That's why you have techniques like view recycling in your recycler view. That's optimizing your layout hierarchies, where you try as much as possible not to have some nested layouts, right? I think that's the power of constrained layouts, right? So you try not to have nested layouts, like everything is just in one particular hierarchy. Okay, so UI rendering is actually very important and impacts your performance optimization, right? Now, of course, you can look at multi-threading, background tasks, optimizing your network calls. All these things are, they affect the performance of your application. Memory optimization, you can optimize your memory, you can optimize your network calls, you can also optimize your database, your battery, like a lot of things, right? So that's just on an more like an overview perspective, right? So, but let's do a deep dive, just a deep dive, right? Now, we'll look at just three basic things under memory management, right? The first one is to avoid memory leaks. And memory leaks occur when objects are unintentionally retained in memory, right? Well, let me use the word unintentionally, because I wouldn't believe that you'd want to intentionally, just leave objects that are not really used, right? So when your objects are unintentionally retained in memory, that leads to a memory leak. And this prevents the garbage collector from reclaiming them, right? And a common cause of this actually is when you reference objects in a long-lived object like activities or fragments. So you can see this screen. You can see this screenshot here, right? You can see the screenshot there. So when you create an object screen, somebody. Okay, can you still see my screen? Please confirm.
Yes, yes, I can.
Okay, so yeah, so you can see from the screenshots that we have there, right? So that you should avoid holding references to an activities context, right? So, but what you should do, if for some reason you need to have that, you should actually just call it in your undestroyed to clear that object reference, right? It's very, very important. So avoid memory leaks like that. That's whenever you're not using an object, or you're instantiating it this way, right? Always kill it. It's very, very important. Very, very important, because that would actually impact the your application greatly. Okay. Now, the next point there is to use what we call the sparse arrays or collections. Now, when you're actually dealing with large number of items, right? One thing you should actually consider using sparse array. Now, you can use sparse array or the array map, right? Array map of, yeah, and those stuff, right? Because use that actually instead of your regular lists or your regular maps, right? Because they're actually optimized. The sparse arrays or collections, they're actually optimized. They actually optimized for that, right? Just like recycler view is optimized, for better usage than, when compared to your normal list view and the like. So you should try to, kind of use your sparse arrays or collections when you're working with large number of what items. Okay. Then for bitmap memory management, right? Of course, some of you, not all of you, have actually been making use of Glide and Picasso, right? Okay, because whenever you're loading large images directly into your memory, that can actually lead to some errors. One of which is the out of memory error. Okay, so you should use technique like image resizing, compression, caching, and that's where Glide comes in. That's where Picasso actually comes in, because they help you to handle images effectively. They help you to manage images effectively. So that's just, a brief about memory management, right? Now, but let's go to performance optimization. So, like I said, the very first one, I had already mentioned it, but let's just kind of talk about it and more of them. Optimizing your UI, that's your user interface. How do you render it? So you should optimize it. So because slow UI rendering, of course, that can negatively impact the user experience. I don't know how many of you have probably opened a website, and then you see uh, the UI components start loading one by one. First of all, you see logo, and then you see option menu. They are just taking their time to just show up. Like none of the components are in a hurry, right? Before just imagine it's Facebook now, right? You open your Facebook app, and then you just see logo first, just welcome you, and then you're going before you even get to. Then the next thing you see the header icons or whatever option menu, like they're taking their time, and you have this what's it called, gray kind of boxes to just represent that something is actually there, right? So it's just showing you that, hey, I'm taking my time, please don't rush me. Before you even get to be asked, your Facebook, what are you thinking of? Is that what they usually ask? And then before even if you're ready to think, before you even type it, the text box has not showed. Everything is just slowly rendering. That actually negative. Has a negative impact on user experience, right? So you should profile UI rendering using tools. That Android has the Android profiler, okay, on your to basically identify. It helps you identify and optimize performance bottlenecks. We get to actually test that out when we're working. We get to use the Android profiler and see how it actually works, right? So optimize your UI rendering, very, very important, right? And one of the ways I said you should do that is try to reduce having nested views. Okay, we'll talk about when you draw views to the UI, right? The second way to optimize performance, of course, is to use recycler views when you want to display lists, right? Of course, you know this already. Use recycler view instead of list view, right? Because recycler view actually it efficiently recycles views and of course reduces memory consumption. So of course you know that. So minimize overdraw, which is what I basically was talking about when I talked about the UI rendering, right? So reduce overdraw. So you need to optimize your app's layout hierarchy to avoid unnecessary drawing operations. So imagine if you want to make a change to your UI, right? If it's nested, right, and for some reason you have to reload, it now has to go down and go in, like just because you have a nested view hierarchy, right? So try as much as possible to optimize your layout hierarchy in such a way that it's not nested or not too nested, right? I've actually seen someone do a UI, right, and then he has a linear layout. Inside a linear layout, he has a relative layout. Inside a relative layout, he has a card view. And then inside that card view, he has a, what did he even use? I think it's still a linear layout also, right? So look at how many layers it will take for the UI to draw, to get down to that particular card view, right? Inside the linear layout to get to that text view, right? That's a lot of words, a lot of steps, right? Of course, that's where constraint layout comes in. With that, you don't even need to have all these things, right? So minimize overdraw, right? Now, another thing is to use async task or coroutines. Coroutines we'll talk about coroutines in our next class, right? And also how to implement it. Of course, some of you have used it, if not all of you, right? So use async task or coroutines for background work, right? So whenever you want to perform long running tasks in the background, right, you should use async task, though it's deprecated actually, but you can basically just use coroutines to kind of prevent blocking the UI thread, right? Anything that will just avoid blocking that UI thread, you should actually try. So you can use async task, though that's deprecated actually, but coroutines is actually better, right? You can use coroutines, which we're going to talk about in our next class, and then get to make use of it, right? Then, of course, I mentioned the Android profiler, right? It's actually a tool in Android Studio that helps you monitor your CPU. It helps you monitor the memory, the network, and battery usage, right? And that just helps you to identify performance issues. So when you run your application on your emulator or even your phone, whichever device, right, either a virtual or a physical device, you can use the profiler tool to actually monitor the impact of what the impact your application has on the CPU, the memory, the network, but everything. You can monitor that using the Android profiler, and that actually gives you helps you make informed decisions, right? Then, of course, properly use background services. It's very important that you use background services and workers. Okay, we'll learn about work manager, right? For tasks that it actually needs to be performed even when the app is in the background, right? Even when the app is in the background. So even when the app is in background, right, you should use background services to handle such tasks, right? But however, actually, one thing we should avoid, right, is running services indefinitely, right? One thing you should avoid is just running a background service indefinitely. do try to avoid that so I can conserve battery life, right? Try to avoid that. Then second to the last, okay, optimize database operations, right? So use efficient database queries, right? We'll talk about Room actually also. So use data efficient database queries, indexing, asynchronous operations when you're working with database, so that it doesn't block the UI thread, right? And then of course the last one there, enable your ProGuard slash R8 and code shrinkage. Right? Basically what this does, right, is that ProGuard is actually a tool. You call it ProGuard or you call it R8, right? It's actually a tool that, and what it does is to shrink, right? Or yeah, it shrinks and it also optimizes and kind of obfuscates your code. Basically, it just removes unused code, right, and reduces your APK size, right? That's basically what it actually does. So of course, you guys should have seen that actually before, right? So it's just okay. Let me quickly just show you how that looks like, right? Let me show you how that looks like quickly. So let me just take a screenshot of my Android Studio and just show you an example. Okay, so okay, so yeah, I want to believe you can see my screen now. Let me zoom in a bit so you can see just in your Gradle, right? So enable in your release, you can enable not debug, right? Because you can do it in debug if you want, but of course when you're releasing your application in the release, you can just add implement your ProGuard files, get the full ProGuard and then pass that, right? So that actually helps you to, you know, it actually is a rule, right? It just has some codes and everything to just help you to remove unused code. And of course, that actually now reduces your application size, right? It reduces the size of it. Because the truth is, a lot of times we get to, when we're writing code, right, we get to comment out stuff and forget. We get to implement a feature that we no longer need, and then we forget to actually take it out, right? Or maybe we have taking it out, maybe we created an extension function, right? And then we are no longer using it and we forgot to take it out of the file, like stuff like that. So that's what the ProGuard does, right? So if you enable that and then the code shrinkage, it actually helps you to, you know, optimize your application, right? So that's actually that, right? Like I told you before, one of the things I want to do is to make sure that we understand concepts, not just we're able to go to Android Studio. We will go to Android Studio actually. From next week, it's all Android Studio, right? It's live coding sessions, right? But it's very important that we understand concepts and what these things are and why we actually even have to use them. Because a lot of times is we are so used to doing, practicing. We go online, we see they are doing, and we are coding along, right? A lot of us have coded along in this life that we cannot even explain per se what we are coding or why it is, right? You can actually just explain based on the context of what it is doing, but not why it should be used, right? And of course, as an intermediate Android developer, you should know why something is used and why, why it should be used. What's the reason behind it, right? What is it even made up of, right? It's very, very important, right? So that you are not just because, let's look at it from this perspective, right? A lot of times when you go to interviews and stuff like that, sometimes they want to just hear what your understanding of something is, right? Because the truth is, if just imagine it, why is it that in jobs, we want to get jobs, right? A lot of tech, and even if you want to get an Android job or whatever, why do they ask you for, how many of them have you gone for, and they give you probably an app or a feature to implement as a test? No, they don't do that. They want to see your problem solving skills. And of course, to be able to solve a problem, you need to be able to understand, number one, understand the problem. Understanding the problem helps you to know which tool or which approach to use. And of course, you can only implement an approach that you understand, right? So let's just bear that in mind. Now, as usual, there's going to be another promotional task this week. then after next week you rest, no promotional task. There won't be any major task, right? Except I just give you an assignment, right? So I'm going to update that, let's say before the end of today, right? So before the end of today, or let's say before 10 a.m. tomorrow morning, check your learning management system, your LMS. You should see your next task. Remember, everything is still boils down to, our notebook application. So whatever we learn about, whatever we teach, we apply it, right? We're going to apply it to the application. And then, yes, you haven't done much yet, right? We haven't done, we haven't done much yet as far as actual implementation is concerned. But there are certain things we can set up, right? There are certain things you can actually set up on the application before you even go and start practicing logic. I've seen some of you have even gone as far as, implementing some other things, right? That has not been said. That's fine, right? It's not really a big deal. It's cool. But one of the things I want you to try not to do. Don't get ahead of yourself. What you know already. Nobody's taking it away from you. But there's a process I'm actually going through. So try not to get ahead of yourself to think that, okay, maybe this is what I would want, because trust me, I may go another direction. So, but one of the things we're going to do is, you have already done something on your application, right? I'll lay down the instructions, right? You've already built something, right? The question is this: as far as memory management is concerned, are you properly managing your memory? As far as performance optimization is concerned, how is your UI being rendered? You're making use of recycler view. Do you have objects that you have created? Are you disposing them? And other, stuff that we'll need to actually check. And of course, the program. So everything we're going to do, of course, is with respect to what I've actually talked about, right? And then, of course, you get to just push that. So that's basically that. Any question before we call it timeouts? I know some of you will be like, I've just been doing concepts. All right, when we start coding, the 2 hours is not even going to be enough, right? Remember when we were just implementing a UI, how long that took, right? So when we get to the actual coding, right, 2 hours won't even be enough. So better I just put out these concepts out of the way, and then we head straight into the actual task. So any question? They are not, I think, probably just call it a timeout. I hope all of us you're all in stage 2, right? Is anybody on this call that is not in stage 2? Okay, so you're all in stage 2. Okay, that's fine. That's good. That's fine. I hope I don't get to drop some of you. Okay, so that's good. So yeah, so that's basically that.